convert scientific notation to standard notation. So let's go ahead and go over this. So we have a times 10 to the b power, right? Well, what does that really mean? Well, let's look at this if we had a number. So our a is going to be the 9.85, right? And so it is a number between 1 to 10, right? And has a decimal after first digit. Right, so it's not including 10, right? It's just a number between 1 to 10. So it's like 1.1 or like 9.9, right? Something like kind of like that. And so what happens is we have this number, right? And then let's go over more. So we also have this b, which is going to be, right, in this case, b is equal to 4. Well, what does that mean, right? Well, b is the number of times the decimal moves, right? And so in this case, we had a positive b, right? So that means we're going to get like a very big standard number, right? Or if it's negative, then we're going to have a small standard number. So let's look at this example below to kind of help us understand this. So example 1, we have the spherical coronavirus virus that have a diameter about the size of 1.25 times 10 to the negative 7 meters long. So let's convert this to standard notation. So let's go ahead and rewrite it. Well, right, so this is our number, right? This is our A, and this is our B, right? I'm just gonna write this. You don't have to write this. It's just to go over this again. So what happens is if we have, right, a negative b, that means we have a small standard number, right? And b tells us how many times we need to move the decimal. And so if we look at our number, what that means is if we have a negative b, we're actually going to move to the left, right? We're going to move decimal to the left. And if we have a positive b, we're going to move the decimal to the right. So if we look at this, if we have negative 7, that means we're going to go ahead and move the decimal 7 times to the left. So what I'm going to do is add zeros, and then I'm going to put 1.25, right? So we're not going to do this anymore because we're going to go ahead and move the decimal to indicate this. So this is telling us how many times we need to move it over. So it's 7 times. So let's go ahead and move it 7 times to the left because it's negative. So 1, 2, 3, 4, 5, 6, 7. So we put that decimal right there. So what does that look like really? So we can go 0.00000001, 2, 5. And this would be in meters. And so that's how small, right, the coronavirus, like virins are, right? That's how small they are. So we say it like this because it's a shorter way to write it, right? 1.25 times 10 to the negative 7, rather than writing it like this. So let's go ahead and look at the next example. Example 2. So the Earth's orbital speed around the sun is 6.7 times 10 to the 4th miles per hour. So let's convert 6.7 times 10 to the fourth to standard notation. So let's go ahead and write this. So we have 6.7 times 10 to the fourth. Right, so this is the number, right? And we have to write the decimal right after the first digit. Right, so that's our scientific notation. And then we have our b, which tells us how many times we need to move the decimal. So it's going to be 4 times, and because it's positive, we're moving it to the right? So let's go ahead, if we put 6.7, let's go ahead and add some zeros. Now let's go ahead and move that decimal, right, 4 times. So we're going to move it 4 times. So it's 1, 2, 3, 4. So we stop right there. So if we were to rewrite this, we have 3 zeros, right, after the 6 and the 7. And then we can go ahead and put the decimal there, and then have a 0 after even. But this is what our number is in standard notation. So let's go ahead and do the final example. So example 3. So what is 4.9063 times 10 to the negative fourth in standard notation? Well, we have a negative b. So that's going to indicate to us that we're moving the decimal to the left. So let's go ahead and add zeros. And then we can go ahead and add this number. So let's go ahead and move the decimal then 4 times to the left. So we go 1, 2, 3, 4, we stop right there. So what does that mean? So we have a number that's 0.0004963. So that is how small it is, right, in standard notation, right? So this is our scientific notation, this is our standard notation.